recap. Okay, what did we discuss? We discussed that given a function y is equal to fx. Now we try to differentiate this function. So what are we trying to do? We are trying to differentiate it with respect to x. Okay, this means if you look at this function, then x is the independent variable. You can choose whatever you want in your mind for x, and y is known as the dependent variable. This much knowledge you also have, dependent variable. Okay, so for every change in x, we're going to find there will be changes in y. That is a very common thing that we all know. But when we do differentiation, we are doing that change for a very small infinitesimal change in x, because you did learn that the h that we are moving is a very small h that we move, tends to 0. So for an infinitesimal change in x, how does the change in y happen? So that is known as d by dx of fx, which is written as dy by dx, which is also written as y prime, which is also written as f dash x, which is also written by the first principle as limit of h tends to 0, f of x plus h minus f of x divided by h. This is all that we had learned in our last class. I hope we are in page now. Okay. And then we started doing some small differentiations, like say, suppose, for example, this is known as the first principle. When you go to your maths classes, you will be first asked to differentiate a lot of functions using the first principle. Yes, that is laborious, but that makes you understand and learn. Say, for example, we do another problem. Say we take a problem and we say that, say, for example, y equal to 3x squared plus 2x plus 5. Okay, and somebody tells us find dy by dx, okay, using first principle. That's all. This is the only last example I'll be doing with first principle. We'll break our head when we do mathematics, but now I need to give you the mixer grinder so that we go in the formula ways first. So how do we do dy by dx? We say dy by dx is given by limit of h tends to 0, f of x plus h minus f of x divided by h. Now start putting it. Okay, now here is where people make the mistake. F of x is this, f of donkey would be 3 donkey square, f of monkey is 3 monkey square. Now we do f of x plus h. So what do? We take 3x plus h whole square plus 2x plus h plus 5 minus the whole thing, 3x square plus 2x plus 5, right? And we divide this by h, and don't forget to put your limit, h tending to 0, right? Let's expand this now. Now this becomes limit of h tends to 0. So 3x squared plus 2xh, so that becomes 6xh, plus h squared, that becomes 3h squared, plus 2x plus 2h plus 5 minus 3x squared minus 2x minus 5. Keep an eye. I may also go wrong somewhere. Okay, so 3x squared takes off 3x squared. That's fine. 2x takes off 2x plus 5 takes off minus 5. Okay, that's fine. Okay, so we go forward. It's limit of h tends to 0. You have 6xh plus 3h squared divided by h. And a plus 2h also is there. Is it right? Yeah, right. Okay. So now what we can do, we put limit of h tends to 0. This whole thing boils down to 6x plus 3h plus 2. Okay. 3h plus 2. Now plug your limit value, because you no longer will be landing up in an indeterminate form. So if you plug your limit value, then it becomes 6x plus 3 into 0 plus 2, which is equal to 6x plus 2. Now that's the gradient function of that function.
Wait, hold on, pause. Hold on. Pause.
Take your time.
Okay, so you took the h common and then you did kata-kati. And then
what I did here was this. The h is common everywhere.
Yeah, I got that.
And then you can plug the limit value, because
and then plug in
The limit
0.
because I don't land up in any sort of an indeterminate form, so I'm allowed to
Yeah.
do that. Okay.
Okay.
What does this tell us? It tells us two things. Okay. Now, don't worry about this process. You'll do a lot in your maths class, but you try to understand what you are inferring from here. Just look at the function that you had got. Your function that you had got y equal to fx was something like 3x squared plus 2x plus 5. Now you'll get your maza. Is it not a quadratic function? Okay. If you see the first derivative, dy by dx, what did you get? The first derivative of the quadratic function was 6x plus 2. Now, this is the gradient function. This is the gradient function. Because you can't find slope of a quadratic function, it's irrelevant because the slope varies. So dy by dx is 6x plus 2. This is the gradient function. Look at the gradient function. Isn't it linear?
Yes.
Yes. So what do we infer from here? Okay, what do we infer from here? Don't cross-check my graph, because nowadays you are an expert in graphs, so I might be wrong. So this 3x plus 2x whatever, this graph might be starting somewhere from 5, and this graph is somewhat like this. This is my y equal to fx. Do you agree?
Yes.
Tell me one thing, Trisha, wherever I want to find the slope of this graph, suppose you want to find the slope of this graph or this graph or this graph, the slope is always what? The line angle made by the tangent at this point, because these are not straight lines. Do you imagine? Do you remember? So if you want to find the slope of this graph, don't you think that you have to first make a tangent at these particular points, and then find their angles with the positive direction of x-axis, or positive direction of x-axis being this, being this, being this. Aren't the tangents straight line?
Yeah.
Aren't the tangents straight line? So what is it? Doesn't it not justify that the gradient function should be linear? The tangents are coming out from the gradient function itself. What is the gradient function? It's a gradient. Okay, let me tell it once again to you. Hear me very carefully. Gradient means slope.
Right.
For a line, slope is constant.
Right.
For a curve, slope is not constant.
Oh.
So I will be able to give you a gradient function. I can give you a mold. You want to make chocolate cake, you want to make whatever, raspberry, whatever, plum cake, whatever you make it, the mold I have given you. These points are the various flavors of cake that you are making. But every point satisfies this particular equation only, which is the gradient function, and that's linear. That's why you are getting the blue lines.
Okay.
Is it getting a little bit interesting now?
Yeah, now it's making sense.
For a quadratic function, the derivative will always be linear, because a quadratic cannot make a theta with the positive direction of x-axis. We can't do that. So we can do what? We can only have linears. And in order to have that linear, I need to have a gradient function. Do you get it?
Yes, I got it now. Okay.
Now hang on one more minute. Look at the gradient function. It's linear.
Yes.
If I differentiate it one more generation, then I will get a constant, because a line slope is always constant.
Yes.
And you don't believe me because you don't have the proof. So I need to give you the proof. So
I was going to ask you.
I say dy by dx is equal to 6x plus 2 for the given function. Do you agree? Yes.
Yes.
Now I'm trying to differentiate this once again, ddx of dy by dx. We are going to go to the second generation. This is known as d2y by dx2. We don't call it square. d2y by dx2, which is also read as y prime. This is y double prime, which is also read as f double dash of x. Means you are doing the second differentiation. Okay, this is a second derivative. And we follow the same formula. Limit of h tends to 0. Let us now take f of x plus h. So it becomes what? It becomes 6 of x plus h plus 2 minus 6x plus 2 divided by h, right? Let's take it one step further. So this becomes limit of h tends to 0. It's 6x plus 6h plus 2 minus 6x minus 2 divided by h. Now, if I start canceling them, the 6x knocks off the 6x, the 2 knocks off 2, and this h knocks off this h. The next. which gives me only 6, which is a constant. Because I'm trying to now find the slope of the blue line. The first derivative was trying to find out the slope of the green curve. The second derivative is trying to find the slope of the blue line. The blue line slope is always constant. Put the kid in that blue line, it slides here, she slides down at the same pace. So it's a little bit clear.
Yes.
And
Pause time.
concept, no, little bit more and then pause. This concept, little bit where we'll understand is when you talk about velocity, little bit grade 9, a velocity is change in displacement over change in time.
Right.
And we will introduce calculus here where we'll bring instantaneous velocity. Instantaneous velocity means at that instant, what was your velocity? When the traffic police starts giving you a ticket because of a violation, he doesn't watch your velocity for a long time. He just uses the camera and the camera clicks the shot at one particular instant. And at that instant, even when the camera clicked the shot, there was a short time interval. The shutter falls down. When we're very small, but there's a time interval. There's a T1, T2. So basically, what this we later on as we start physics will say this is average velocity. But when you go for instantaneous velocity at which you are ticketed, in that we say delta T is very small, and it is delta X by delta T, and there we say it is dx by dt. This is V instantaneous at which you were ticketed. And what was your instantaneous acceleration? Acceleration is rate of change of velocity. So it is d by dt. Can dv by dt written in another form? Oh, why not? V is what? V is dx by dt. So there you say d2x by dt2. That's the concept I'm trying to develop for you. How to see the second derivative. First derivative is function with respect to independent variable. Second derivative is derivative with respect to independent variable. I rest it here. You can copy it out. If you don't understand anything, please let me know. But don't worry about the thinking that is going fast. We will go as slow as possible.
Absolutely.
Okay. As you copy it down, let me also keep speaking. See, I tried to start today with recapping what we had learned in our previous class, that what is the generic formula to find the derivative of a function using the first principle. And I took a simple problem, which I took a quadratic function, and I tried to differentiate this quadratic function with the first principle to find its first derivative. After I found the first derivative, I tried to show you graphically what have I done. I have given you slope. No, I have given you the slope function because we are dealing with a curve. I can't tell you what is the slope unless you tell me where you want the slope. Do you get me? I can't tell you the slope unless you tell me where you want the slope. Mark my words. So you said, I will find the slope wherever I need. You give me a gradient function. I said, okay, then take the gradient function. So the gradient function happened to be linear for a given quadratic function. Now, if your given function was a linear, the gradient function will be a constant function because a straight line does not have variable slope. And if you want to further proceed on these problems, since you have now got the value of dy by dx, which is equal to 6x plus 2, Twisha Sharma can say, sir, you gave me the mold and I tried to make a raspberry cake out of it at x equal to 2. You are now interested to find slope at 2. So you say 6 into 2 plus 2, which is equal to 12 plus 2, which is equal to 14. Now you'll say, look, sir, I got a constant out here. I said, yes, you got a constant because you have fixed up a particular blue line now, and you're trying to find out the slope of that blue line. So there is nothing wrong in you getting a constant. And to more better understand, it was this particular point. You tried to find out the slope here, and say, what is the slope at x equal to 2? On the slope at x equal to 2, this blue line is what I'm trying to find the slope of. And the blue line is a line. So obviously its slope will be constant. It's 14. Finished. Hey, I want you to love this. I don't want this to be means culpable with you. So anytime you feel that anything is going OHT, anything is Hebrew and Latin, just do not hesitate. But if you love
after I'm done writing, I want to graph this on my graphing calculator and see.
Yeah, you please graph.
That's what I want to do. So I just want to write a little bit and then I'll do that.
Yeah.
Mhm.
Well, as you are fetching that soda, you know, it's very what do you call, selfish on your part that the teacher doesn't gulp. So can he get one muffin or something? Okay, let
I'm
me.
absolutely go get something. Wait, question.
Yes.
Okay, so here we had a quadratic, which we differentiated it once,
Mhm.
and we got a linear.
Yeah, the degree will always come down by 1, as simple as that.
Right. Yeah. Now, my question is more okay, and then we differentiate it again to get a constant. Now, the constant is the slope at that point.
No, it's like this. When you look at the very good question, when you look at the quadratic, you're looking at the green curve.
Mhm.
And when I say green, I say curve. It's not a straight line.
Right.
Can I obtain a slope for it? No, you can never obtain a slope for it because the slope will vary at different points.
Right.
So what do I do? But you're still interested in slope. So I said, look, ma'am, I can give you a slope function. Take this function with you. Whichever point you are interested, plug your point in that function and get the slope at that point.
Right.
So you got a slope function which was 6x plus 2. Now this is your mold that you're carrying with me. And there are 3 dots on that curve. These 3 dots were your point of interest where you wanted to calculate the slope. Obviously, if the child is sitting on the green curve, the child will slide down with different velocities or different
Right.
field. So at these each 3 points, you wanted to find out what is the slope. So once you know the value of the 3 points, say x equal to ABC, you plug ABC, it's 6a plus 2, 6b plus 2, 6c plus 2. These are the different slopes. And these different slopes are actually the slopes of the 3 different blue tangents that I have drawn. In order to quantify the example, I specifically took and said that let x be a point x equal to 2. So if you see the violet or the lilac color that's there on the right hand side, there what I've done, dy by dx at a particular point x equal to 2. And again on the left, I have tried to show arbitrarily what is x equal to 2, and I got the value of 14. Now the question comes is that if the gradient function is quadratic, then the if the main function is quadratic, the gradient function will always be linear.
Yes.
When I say linear, for this time, slowly now omit the green from your mindset. The green is gone. At x equal to 2, we are at x equal to 2. Okay, we are not seeing the entire green. We are at x equal to 2. At x equal to 2, the green has now been omitted. By what? By the blue line. Because you cannot find slope of green. You can only find slope of a blue line. So what is the blue line? The blue line is 6x plus 2. It's a linear. Line means linear. And how much did you calculate the slope of that line? You calculated that the slope of that particular point, at that particular point, it is equal to 14. Okay. So it's you found out that 6 into 2 plus. Right. Did you get it? Now,
okay, let me just make sure I got that. So essentially, first differentiation, you'll get an equation to find the slope. Second differentiation, you'll get the slope at a given point.
No. First differentiation, first is function. Differentiated, you get the slope function.
Right.
Slope function can also be differentiated further. Why are you thinking like this? Let us assume that our initial equation was a cubic equation. Cubic.
Right.
Our initial equation was cubic. Then what is the gradient function? Quadratic. At every point, it will be some quadratic curve, small curve. Then if you do the next generation differentiation, what you get? Linear. Then if you do the third generation differentiation of that linear, you will get what? You will get a constant. So value of, see, once again, I'll tell you, look at that equation, it's 6x plus 2. If you compare it with y equal to mx plus c, you should say that the slope is 6. No, the slope is 6 for that blue line. See, y equal to mx plus c, m is slope, right? Yes. So what is your slope function? 6x plus 2. Then you will say, sir, how did you get 14? You should have got 6. 6 is the slope of the blue line. And that is exactly what we got. If you see the bottom right portion, when we tried to differentiate the blue line, we got 6. It marries with our thought. But 14 is not the slope of the blue line overall. 14 is the slope of the green line. Taking the help of the blue line. 14 is the slope of the green curve at x equal to 2.
Mm-hmm.
Did you get it?
Hold on. Hold on.
Look, 6x plus 2 is a line. Do you agree with me?
Yes.
Can it have variable slopes?
No.
No. If I say that the three tangents are represented by 6x plus 2, you will never agree with me. How can three different tangents be represented by the same equation 6x plus 2?
Mm-hmm.
Just follow what I'm trying to say.
Mm-hmm.
How can three different tangents be represented by one equation called 6x plus 2? It's not possible.
Oh, yeah.
6x plus 2 is a one particular unique line.
Yes.
One tangent may represent it, but three tangents cannot represent 6x plus 2.
Mm-hmm.
So there is what it gives you clarity. 6x plus 2 is my gradient function, not those tangents. It is the gradient function of that particular line. And that gradient function changes its orientation every time depending on where you want to find the slope. But if I take a line which is 6x plus 2, then its slope is constant, it's 6. No doubt about it.
Yes.
Now, if you try to find out the slope of the green curve at x equal to 4, our slope will become 26. 6 into 4 is 24 plus 2, 26.
Mm-hmm.
Obviously, let's take the second red dot as x equal to 4. How much did we find our slope as? Sir, you found it as 26. The slope is more than what it is at x equal to 2. How do you say that? Look at the curve also. The curve is also rising. If you draw the two tangents, this tangent will be more steeper than the previous tangent. Theta will be more. Theta will be more, tan theta will be more. As simple as that. So the slope increases. If you would have gone to the third point, look at the graph's nature. If you would have gone to the third point, say it is x equal to say 7, then our slope would be 44. The slope increases further.
Mm-hmm. Okay, so the first differentiation is a stepping stone to find the gradient function.
Gradient function of the given curve.
Of the given curve.
Yeah.
And the gradient function is what tells us the slope.
How the slope will vary in this function across any point. How the slope is going to vary. The gradient function helps you determine the slope at any point of your choice on that green curve. At any point of your choice on that green curve. Makes sense?
Then I need to change some things I've written. Okay, yeah.
Makes sense?
Mm-hmm.
Once you found the gradient function overall has a linear nature. And you want to differentiate that linear function, obviously you will get a constant. A linear function cannot have a variable slope. That much I want you to understand till I just wash off the caramels of the donut from my fingers. Okay, give me a minute.
Yeah.
What you asked me right now is absolutely bang on, but I just wanted to add on to your understanding, not to what you asked me, a little bit more. Once you got your gradient function, if you differentiate, I'm just trying to tell you that the gradient function is linear. So if you differentiate a linear function, now you are going to get a non-variable slope because your given function is linear, madam, linear. That means the slope that you're going to get of the linear function is going to be constant. That's what we got. 6 is constant.
Yeah.
Slight a bit in control.
Yes.
Or is it gibberish? No.
Like when you said that all the tangents are different and like if you look at the slope of the tangents, they'll all be different. That's when it clicked in my head.
Yeah, it's all different because it has to be. That's why I gave you a mold. The mold is same. The taste of the raspberry cake cannot be same as the taste of the vanilla cake. The shape is same.
The gradient function will never have like an H term, right?
No, when you're trying to differentiate the gradient, if you take the gradient function as a normal function, and then you want to differentiate it, then you will always have a H. Say what I'm trying to say. You now got something called f dash x, right? And f dash x value is 6x plus 2 in your example. I can also assume it to be one function called gx. Who's not? And I am now interested to find what is g dash x, which means I am differentiating d dx of gx. which
Yes.
means I am differentiating the original derivative function fx, f dash x.
Yes.
So I write this as f double dash x, means is the second derivative. And
Mhm.
now I make it as limit of h tends to 0, okay, f
Mhm.
dash x plus h minus f dash x divided by h, which is also same as limit of h tends to 0, gx plus h minus gx divided by h, because gx is nothing but f dash x. That's what we have assumed.
Right. Yes.
But no, you can't, the thing which holds true is that the derivative will always be given by this particular formula. And instead of writing f double dash x out here, I write it as g dash x. First derivative of gx is same as double derivative of f dash x.
Right.
So if you little bit try to marry kinematics, then I'll say that acceleration is first derivative of velocity or second derivative of displacement. This is what is the concept that I'm trying to bring. Acceleration can be seen as first derivative of velocity or second derivative of displacement, because displacement's first derivative gives you velocity, and you are again.
Right.
So acceleration is the grandchild of Daddy Pig. Grandchild.
Yes.
Grandchild.
Yes.
And Peppa Pig is the first child of Daddy Pig.
Yes.
Peppa Pig's child would be acceleration. So you can either say dd of Peppa Pig or d2 of Daddy Pig, as you want.
Can you go up a little bit?
Why not? Does
Yeah.
that, we are no more now into this, what do you call, laborious first principle. You have understood first principle a lot. Just keep it in your mind one thing. Given cubic, derivative is quadratic. Given quadratic, derivative is linear. Given linear, derivative is constant. Given constant, derivative is, go on, tell me. Last one.
Given constant, derivative is,
Given cubic, derivative is quadratic.
yeah, 1.
Listen to me and always remember that child and the graph. Don't answer quickly. Listen to me. Close your eyes and listen.
Okay.
Given cubic, derivative is quadratic. Given
Yes.
quadratic, derivative is linear.
Yes.
Given linear, derivative is constant. Derivative means what? Differential calculus is all about the word beginning with S. What we started our discussion with, the topic with S,
slope.
Slope. Slope is constant.
Yes.
So what should be the derivative of that? A constant.
Inverse? -1 power is
No, a constant function. A constant function, Tushar, is like
zero.
ladder. Yes, zero.
Zero.
Child doesn't slide. Yes, child doesn't slide at all. So given a constant, the derivative would be 0. You are the first person who now knows this, and now you see the formula, how nice it behaves. So you got it?
Okay.
When you find derivative, the degree reduces by 1, 1, 1, 1, 1, right?
Yeah.
Don't write anything. Let's see one more thing, and then you can write. It will reinforce your learning by that time. Okay, shall we go ahead?
Okay.
Shall we? Okay. So what I just tried to say was something like that. If the function is cubic, if the function is quadratic, if the function is linear, and if the function is constant. Okay, let me look at the degrees. Okay, that's why polynomial was very important. Degree 3, degree 2, degree 1, degree 0, right? And by the time you come here, your expression is free of x, free of variable. Do you agree or not?
Yes.
Constant means free of variable. Variable is there, but you can't see it because it's x to the power 0 equal to 1, right? Now I'm saying my derivative out here. Derivative means I'm on the first derivative now. Obviously, the first derivative here would be, okay, let me not write it like this. it will make you more understandable. You should understand. And here the derivative will become Constant's derivative is always, Constant's derivative is 0. The first person who has learnt it this way, at least from my hand, you've understood it. By teaching, you also gain different ways you can understand. Now, enough of those mixer grinder methods. Time to give you, relieve you from a little bit of all this hard work and labor. Shall we go into formulas now?
Table banana, then we can go in formulas.
Okay, fine.
Okay.
You will not let me progress.
I will never let you progress, sir. It's my job to annoy you.
Yes, you will not let me progress. A frog climbs 3 feet and slips back 2 feet. What is the climb of the frog per day? Sir, 1 feet. How long does it take for the frog to climb a well of 30 feet? Sir, 30 days. Because the well is Tushar Sharma.
Thank you. Thank you.
Walls are slippery. The frog can't grip. Wants to, slips back.
See, sir, देखो आप ऐसे नहीं कह सकते. आप भी मेरे बिना बोर हो जाओ.
और नहीं तो क्या? I love that. Teaching you is always a privilege.
Thank you.
Right. So we now go for formulas. And this is where your physics will be handy for you, because you are not studying mathematics. And this is what the biophysics, chemistry students back here in India, they mug it up because they don't understand this part. That's where Karunya was having problem. Formulas for evaluating derivatives of functions, right? When I write this word formulas for evaluating derivatives of functions, the first question that comes up is that, sir, how many formulas do I have to remember? So you have to first see how many culprits, that many types of laws you have to make. Functions, Madam Sharma, we have functions of this format. Ilate.
Oh.
Inverse. Logarithmic. Algebraic. This is your favorite. This exponent. Now you feel how your ma'am was teaching you. You have a fair bit of idea about this function. You have an idea about this function. You have an idea of polynomial function, this. And don't worry, we will.
Trigonometric functions pre-cal में आएंगे ना फिर
We will sail you through these two. We'll sail you now.
Inverse the idea hai, because inverse we did.
We will do. No, these are not the normal inverse. These are inverse of trigonometric.
Of course. Why would it be normal inverse?
Yeah,
Why would they be nice to us?
A very inverse is the most cancerous function that I can tell you. Okay, so as long as it stays away from you, be very happy. These are different functions. We start with
inverse and trigonometric functions in pre-cal then? Is that what they're going to do?
Should be first you have to be trigonometry, then comes like here in 11 we study trigonometric functions, and in grade 12 we study what you call inverse. Inverse is 1 generation advanced. Maybe may not be. I need to check that. Okay, we start with algebraic, which is the cutest of all. Okay, the cutest of all. So I won't write algebraic. I would write our first function in a generic form of an algebraic function where y is equal to. Are you with me now?
1 sec.
Okay, don't write every line.
Oh, I have to.
Listen the story. Okay, Ilate. And today I don't have any books or notes. I'm teaching you whatever is coming.
Yeah, no, trust me, I know. I have noticed.
Yeah, so that helps me because I feel this way. Maybe teaching someone like you for 2-3 more years, you can make a concise doc and publish that. There are books of calculus, but if you go this way, your physics becomes easy. Obviously, you're learning to drive before you are 18-year-old. So we are driving in the backyard within our compound, not within the law. Okay, so y equal to a function which is ax to the power n. I hope you understand and you're able to read it. A is the coefficient. Or in your language, as ma'am says, leading coefficient, okay?
Yeah.
And n is my power or index or exponent, whatever you say, and x being the variable. Now, always remember variable, or which is also known as the independent variable. We always differentiate with respect to the independent variable. You may ask me, sir, what is the value of dy by dt? I would say, listen, what I'm saying, I'm changing my words, dy by dt. You are trying to differentiate y with respect to t. T may be some variable. I would say that is 0 because here the expression is y in terms of x. T is also a variable, but T is something different. How come you walking in the country of Cuba with the currency of Indian rupee in your hand? Do you think you're going to buy something? No. Convert it into a common currency and then only you will be able to transact in Cuba. Do you get my point?
Yes. Okay. So you always differentiate in terms of x.
The independent variable. So if my function was something like this, listen to me, y equals to 3t square plus 4t plus 2, then dy by dt makes sense. We are in Cuba and we are with the Cuban currency. But that time, if you ask me what is dy by dx, you're trying to buy something in rupee in Cuba. No is the word. Got it? Unless and until you trade in a common currency, and that is also what we're going to learn sometime later. Did you understand? It's only the function, ma'am. I need to write the formula. You're happy looking only at the walnut. Let us crack it, and eat the fruit inside. Can I, with due permission?
Yes, absolutely. Let's go.
Okay. So you're fascinated in the fruit market. Whatever you're seeing, you're liking it, and you're writing.
I'm having a great time in the fruit market, sir.
So now, for such a function, the first derivative dy by dx is given by whatever is the power that comes outside. Got it?
Right.
Then the coefficient a, then the variable. You will not write anything. You will wait for my permission. And the variable gets reduced by 1.
Right.
Okay. Hang on. Example. Y is equal to f of x is equal to blah, 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 blah. What was it? It was 3x squared plus 2x plus 5. So it's 3x squared plus 2x plus 5. You remember what did we get? We got this as 6x plus 2, if you remember. So let's try and put the formula here. Dy by dx, you will do for individually, you can do. Each of them are again like functions, quadratic, added with a linear, added with a constant. So we can also add the derivatives. That I'll tell you just after this, but I just wanted to get the flavor of this formula. So the first one, the coefficient, the power comes, the leading coefficient stays where it is, the exponent is 2 minus 1. Okay. For the second one, this is the coefficient. So the power comes, then the coefficient, then x, 1 minus 1. And for the third one, this is like x to the power 0. So 0 comes outside, then then the 5, followed by x, and then 0 minus 1. So let's evaluate this. This is 6x to the power 1 for more simplicity, plus 2x to the power 0, which is equal to 6x plus 2. This is the beauty of the mixer grinder, which you were doing in the laborious process into so many steps. Did you get it? And then, and wait, don't be happy now itself. If we say that we have a function gx equal to 6x plus 2, and we are interested in finding g dash x, which is equal to d by dx of gx. We are trying to differentiate gx. So now you know 6x1. So 1 comes outside, then 6, then x, 1 minus 1. And for this term constant, I'm no more writing. Okay, let me write. 0 comes out. This is like 2x to the power 0. 0, then 2, then x to the power 0 minus 1. So obviously it is 6. That's what you got, 6 as the.
That's the slope. Yeah.
Did you get it? And hang on. If you ever get a function hx, which is a combination of functions like fx plus gx plus kx, say it's a combination of function, then ddx of hx, which is nothing but h dash x, can be said as finding the derivatives of each of the functions individually. That's what you did in this.
This is what we just did for the quadratic.
So don't be only stepmotherly attitude with plus, give equal love to minus also.
of course.
Now you can write whatever you feel like.
Okay, fantastic.
This is your first formula, and I mean, this formula would be like something like, it's like the screwdriver in a house. It will be used extensively. Extensively.
Okay.
Done?
Yes.
Okay, couple of examples on these type of problems. So one more example would be something like example of, okay. Our next example is f of x is equal to 4x to the power 4 plus 3x squared, and we want to find out what is f dash x. I think now the easy way to how to do it easily. Okay, how to do it easily. Look at me. Always straight away multiply these two. Always straight away multiply these two. So let's multiply this. 4 into 4 is 16, and then retain the variable as it is. Just reduce the power by 1. So that's 16x cubed. Done. 3 to the 6x. That's it. Done.
That was quick. Yeah.
Mixie, then super mixer grinder. Now, if you want to find out f double dash x, this would be equal to 3 into 16 is 48 x squared plus 6. If you want to find the third derivative of x, that would be equal to 48 into 2 times. You will use your calculator, which I won't. So that's around 96x plus 0. And if I want to find the fourth derivative of x, that would be the constant 96 only.
Yeah.
Why I did this? So that you get a flare of understanding that how this thing works, how this thing works. Here it's x to the power 1, so it's a 1. Here it's x to the power 0, so it goes away. It's 1.
Yes.
And this, if you do the fifth derivative of this, then it will be multiplication with a 0. So if you do the fifth derivative of x, then obviously you get a 0 because you're multiplying with the 0. Yeah. Did this get inside your head?
Yes, I'm clear on this because
if this got inside your head, then how about now saying f of x is equal to 1 upon x squared. Why, sir? You're doing all these things. No issues. So f of x can be written as x to the power minus 2.
Yeah.
So f dash x can be written as what? Minus 2.
Negative 2 times.
Minus 3. So this time it becomes negative 2 by x to the power 3. So here, what is the relation that you see? The relation that you see is that this particular fellow goes up, gets a negative, and then the bottom gets increased by 1. Just look at it.
ये तो बस वही power of exponents. Laws of exponents.
Okay, did you understand?
I'm good.
Now one more.
Right.
Example, f of x is equal to root of x, which is equal to x to the power half. So what does f dash x become equal to? Half x half minus 1, which is negative half. So it is 1 half root x. Okay, fine. We're done with algebraic.
Okay.
Time to move on. Oh, you'll write again?
No. What are we moving on to? I'm just gonna write again.
Don't tell. Right.
Yeah. Okay. I'm gonna write that
the
last
first class in the universe where the class notes are copied at the same time. They're being recorded. They're being saved into a PDF.
Can you do a cubic one?
Oh, why not?
Can you like a cube root?
Cube root, why not? Take it. F of x is equal to cube root of x. So what is it? It's x to the power 1 by 3. So f dash x would be equal to 1/3 x to the power 1/3 minus 1. So it becomes x to the power minus 2/3. Okay. So it's 1 by 3 x to the power 2/3.
Okay.
If you want to write it in more stylish way, it's 1 by 3. It's cube root of x squared.
Right. Okay.
Shall we go ahead?
Yes.
Okay, right. So now I think we're done with the algebraic formula. Okay, the algebraic formula is done. So we move to some of the trigonometric formulas. Okay.
Great.
So we move to trigonometric formulas. Okay. The first one would be if y is a function which is equal to sine of x, then dy by dx is cos of x. Very easy.
Okay.
Why was this teacher actually saying that it will take your life away? Y equal to cos x, then dy by dx is given as negative sin x. Cos in whole calculus is very bad. Cos will always turn everybody negative. Remember this word of mine. Cos is bad. Cos is bad. Cos
Right.
will turn everyone negative. Okay.
Right.
Okay. Third formula. Y is equal to tan of x dy by dx is equal to sec square x.
Okay.
Fourth formula. Y is equal to sec x.
Well, there's more.
Dy by there are three males and 3 females. Sin cos tan. Cosec
I was just about to ask you to recap कौन किसकी बीवी
sec
है.
x, tan x. Yeah, we'll do that. Sin's wife is cosec. Cos's wife is sec. Cot's wife is.
पहले वो लिखना पड़ेगा मुझे.
Okay. Then we'll write these also. Okay.
Yeah.
Sin x is equal to 1 upon cosec x. Cos x is equal to 1 upon. This was the time when you left India, right? When we were learning this, I think, because we started trigonometry at grade 10, you were there. I remember that.
Yeah.
Tan
Yeah.
x, you remember I brought those forceps from my kitchen, the roti forceps.
Yeah, I remember the forceps.
Yeah, so yes, so 1 upon cot x. Now look, 2 more formulas which will come out from here. We are pending with 2 more. Look at it.
Yeah.
Okay, if you know the first 2, rest can be rest. If you fall in trouble, you can find them. Look at, but I want to tell you these 2, then I'll leave you. Hang on, watch me. Now I'm still left with what? I'm left with dy by dx of what? Of sec x. So sec I have done, cosec I have not done. Cosec x. First of all, try to point out cosec is the wife of whom?
Cosec is sine.
Sine. Okay. And sec is the wife of cos.
Right.
When you tried to do d by dx of sec x, what did you get? Sec x tan x. Now, I'll try to give you some story. You just try to follow. Cos's wife sec says that when you differentiate me, you get sec x tan x.
Right.
Sine's wife cosec always has a hidden, what do you call, competition with cos's wife.
Right.
Sine's wife has a hidden competition. Mrs. Saxena is always having a competition with Mrs. Malhotra. You know, I got Kanjivaram silk. So what she'll say, I got some pure silks. She also say her display of it. So what does she say? If this is sec x tan x, then this fellow will be, instead of sec, it will be cosec. Instead of tan, it will be cot. And you are plus, so she says, but my husband, you know, he got it from Italy. So negative will come. That's how you remember. Now, the last one, y equal to cot x. Now, when you look at tan x, its derivative is sec square x. So when you look at cot x, you try to put your common sense. If tan was sec, then cot should be, cot is reciprocal of tan.
Yeah.
Sec is reciprocal of cos.
Yeah.
So this will be reciprocal of sine. Cosec square x. But definitely all the c's are big culprits in calculus. In calculus, once you see a c, its derivative will always be minus. Once you see a c, its derivative is always minus. Once you see a c, its derivative is always with minus. These things are not written in books. These are the 6 formulas of, initially for you to begin with, I would always want that this should be down your throat, this should be down your throat.
Okay.
And if this one also, but the third one we can also, we can derive on our own if we land up in problem. Rest of the 3 usually doesn't come that much in physics, but in mathematics, they'll come extensively.
That's great.
Ma'am, we are still left with exponential and logarithmic.
नहीं, कोई बात नहीं. Let me live in delusion.
Yeah. Inverse, I'll not teach you now. We don't need that for physics.
Wow, thank you, sir.
So you just remember sin x becomes cos x becomes minus sin x.
That's fantastic. यही सुनना था.
Okay, I'll just tell you one more formula. In exponential is very cute. We have one formula only, and then we're
That's
done.
very nice. That's
Yeah,
very
I'll
nice.
not tell you logarithmic today. So what we will be using, okay? Exponential. See, at the end of the day, I should always serve you a dessert so that you, whatever spices you ate, that should get neutralized, as well as you should feel happy that the host served you a good dinner. So if y is equal to e to the power x, okay, can you guess what is dy by dx? It's e to the power x.
Wow.
I could not have given you a better ending than this. Okay, if
Oh,
y is e to the
nice.
power x, dy by dx is e to the power x. And if you are interested in a little bit of pan masala, so I can give a little bit of pan masala to you also. Here also,
I was just about to ask.
no, here also I'll tell you only one formula, and it will be like a pan masala. Y equal to, okay, now this is what I'm writing. Since I am habituated to write this in calculus, you watch the word log means it is always log with base 2e, whereas foreign books will always write it as ln x.
Yeah.
There's nothing called log 10. There's nothing called log 10. It's log means to exponent, natural logarithm. So dy by dx is 1 upon x.
That makes sense.
That makes sense. That's easy.
Okay. Yeah.
Okay.
Okay. Yeah.
Fine.
Question: Is there only one formula for logarithmic, or
there
are
is
there
one more, but we will unfold it later. I mean, there's no point in you're not able to digest so much of spices. We'll do it later. But we don't require that so much in next class. What we would do is that we will go to the algebra of differentiation, the product of differentiation, and the division of differentiation. How means it's something like this, that in our next class, coming next week.
Next episode.
Coming next week. So I should show you a blooper for that. So coming next week, we will see how do you compute dy by dx if A, you have f of x plus minus g of x. This you already know a bit. You compute individually their different, their derivatives. This you totally don't know, f of x into g of x. And this also you don't know, f of x divided by g of x. This also you don't know. In fact, to just create the eagerness in you, you don't need to remember tan of x later on, because your tan of x is just a sine of x by cos of x. So if you know how to find out this particular thing, you would be able to find the derivative of tan of x. Why only tan of x? Sec x also you would be able to find out. And why only sec of x? You should be able to find out what is cosec x, which is also equal to 1 upon sine x. So if you observe, this is trigonometric by trigonometric, algebraic by trigonometric, algebraic by trigonometric. So once you know this, the rest can be found out.